Good morning or good afternoon, or good evening, depending on when you're watching this. We're going to do the third part of our robots and marbles tutorial using cadCAD. So in our last video, we did a live code building, just copying block by block of the configuration file for our robots and marbles. And in this example, we're going to add another little complexity and show what that is, and then run it and show what the different results are, as we've been building complexity from stage 1 all the way up through tutorial 4, and eventually there's going to be some more tutorials. There's currently one we're working on that will include Network X, which is a graph theory tools to show how with cadCAD we can integrate other scientific Python libraries to add more features that are not possible in other tools and allow for more complex analysis. So a brief recap here, we have the robots and marbles. I do recommend going back if this is your first video to just flip through the other videos that we've had, part 1 and 2, just so you're familiarized with the concept. But I'll briefly go here. This is our overview, our whiteboarded example of what we're talking about, where we just have a robot, we have a process, and we have boxes of marbles, box A and box B, and the robot is trying to make the boxes have the same amount of marbles in them. So what we have then, when we have our high-level idea of what we're doing, then we convert it down into the syntax, which we're soon going to be having a little guide that we're going to be releasing that explains what these different components are. You don't need to use this process, but for us, when we get more complex systems, more complex than this, it's just good to always start doing the right process from the get-go. Helps us solidify our large ideas down into a graphing format that then we can put into code. We have, in this tutorial, 2 behaviors. We're having 2 robot arms, because in the real world in complexity, you don't usually have one. You have multiple actors that are doing different things. They have different thought processes and optimization points. So we're having 2 robot arms here. They're each controlling an arm that is trying to increment their box of marbles. So we have 2 states, box A and box B of marbles. So what we're going to have here is the difference in our process here is we're having robot 1 acts every 2 time steps, and robot arm 3 acts every 3 time steps. So they have a different policy, and they're going to act a little differently. As the goal here is we're trying to get to equilibrium, but the arms are going to operate slightly differently. So let's pop over to the configuration file and see kind of what's changed from last time. Last time, remember, we did the coding example from scratch. We deleted some of these things we didn't need. We're doing 1 run. We have 10 time steps. We have behavior, which is the robot arm, which essentially is trying to make sure the boxes equal the same. And as we talked about in the first video, we try and go to, when we're initially trying to make a system, we try and first go to math and define what our behaviors and things, instead of just writing in code here, like, what am I trying to do? Am I trying to, if we can do it in simple math, I'm trying to equilibrate the boxes. So here we have the robot periods. This is new. We have a list that shows, remember, robot arm 1 acts every 2 time steps, robot 2 acts every 3 time steps, and we're defining the behaviors here. We're not going to use this behavior anymore, which is our old robot behavior. So we will just comment this out. I'm commented out things we're not using. In Python, comments are just these hashtags right here. So we have the 2 list here, and then robot arm 1 is showing every time step. We are going to operate every 2 when they're equal multiple of 2, and then that's where we're going to call. So we need this. We're calling this robot arm thing because this just equilibrates. This behavior right here is stating that we want to go every 2 time periods. This one says we want to do every 3 time periods because it's calling this list here and seeing where the correct part is, and then it calls this robot arm, which pertains our logic. Our mechanisms stay the same, which is essentially like however many we have here, we're going to be adding to that box, and we're adding to the other boxes. Arm 1 controls increment A, which is box 1, and robot arm 2 controls box 2. And we have, starting with our states, starting with box A has 10 marbles, and box B has 0 marbles. And then what we have here in the policy section is slightly different. Instead of defining 1 robot and 1 robot arm, we're defining 2 robot arms, as they're both acting independently. The rest of these parts are the same. And then when we come in here and run, our results, We have something slightly different here. As you can see, they act every, initially it's starting the same, they only act every two time steps. So nothing happens the first time step. So 0 is the starting, 1 is the first time step. And then we have some kind of interesting activity. We stay here for a little bit at 7-3, and eventually we hit the equilibrium. And if you see eventually in our initial example, it was 10, 9, 8, 7, 6, 5, bam, then we hit 5. And this was 0, 1, 2, 3, 4, 5. And then we just equilibrated at 5, I believe, at time step 5. Versus here, or I guess it was still 6, the action is a little different. So when we graph it, we get this weird shape. They're still hitting the equilibrium, which we want, but there's a little bit more variation here. And we will have these tutorials posted, as you can see kind of the logic of exactly what happened here. I wrote it out for you, of exactly what happened, how they worked. It's slightly complex, but as you can start seeing, you can have behaviors of different actors interacting with each other, and that adds some more complexity, more real world interactions, which when you're trying to do modeling of behaviors and things, behavioral economics, or just trying to see how people are going to interact with your platform, these type of features of having these interactions and different behaviors become very important. It's a great part of cadCAD. Well, as always, thank you for watching, and let us know if you have any questions in our Telegraph channel. And this notebook will be posted on our GitHub page. Thanks.